overview of the NCEP air quality forecasting and the global dust and aerosol model。等一下请王博士自己介绍。下面这一串 NOAA、NWS、EMC， 还介绍它到底怎么制作。我就不多说话。王博士呢是台大毕业的，然后到美国去了2个学校在那边拿了博士。他最近10几年就一直在努力投入大气化学模式的发展和应用。他是 regional model 然后 regional to global model couple， 然后他也可以把 regional 空气品质模式跟 regional 气以后变迁模式的couple 的关系的联系，他都投入过。他今天呢给我们介绍现在最近几年在美国做的就是有关这个 NCEP 的是美国这个 NCEP 是美国很重要的一个机构，像大家搞模式的、搞资料的都对 NCEP 有一些认识。他们现在在发展中的那个 air quality forecasting 啊，然后这个我是欢迎的。
Thank you for inviting me to give this talk. My present organization is responsible for the U.S. air quality forecasting. The NCEP, the National Center for Environmental Prediction, also responsible for the global and regional meteorology forecasting. Several years ago, due to the demand of the U.S. Congress, we started the air quality group in this unit, and we are doing this air quality forecast since then. And these are either my co-author or my supervisor and the project manager in the NOAA headquarters. Our unit is under the National Oceanic and Atmospheric Administration, and below that is the National Weather Service, the National Center for Environmental Prediction. And my limited affiliation is the Environmental Modeling Center, which is under that one. And we also have one office of project manager from the NOAA headquarters, Air Resource Center. The purpose of this visit is because we have very strong regional air quality group here, and although we are responsible for the air quality forecasting, there are several things we would like to improve the forecast in the future. So we hope that this visit will establish a collaboration between two institutions. Today my talk will be a quick overview of air quality forecast system, because this system, although is the main player is the air quality model, but it involves the global meteorology and also research model. So it's a very complicated discussion for the whole three models. I will do a very quick overview, and I also will introduce our operational status, including the requirement, criteria for doing the air quality forecasting, and our future development. The NCEP air quality forecast system basically is driven by the regional meteorology model, which is a world model, weather research forecasting model. And however, we have our own version, which is different from the regular world ARW. The reason is that we are operational unit, so sometimes any too complicated mechanism does not meet our time criteria. So there's some modification in order to satisfy using the minimum time to achieve the maximum accuracy. And our chemical and transport model is a CMAP, which is developed by US EPA. The operation, we started with the global meteorology model and used the output to train the regional meteorology model. And therefore, we provided a map field for our regional chemical model to drive to produce a chemical field for our air quality user. Although we are responsible for the simulation, but the real forecast responsibility is at the state. So we are providing a guideline for them to use our product in order to perform an air quality forecast at different states, including issuing a warning for the deteriorated air quality. This is a brief. I'm not going through. I just some people might interest, some people might not interest in the detail, but this is our global forecast system. Including this spectral model, we have, at present time, we are going at T382, it's about 0.3 by 0.3 degree. These are hyper sigma p for other topics up to the 0.2 millibar. And we have mainly have ozone physical algorithm to describe the ozone field or the radiation. And we use the different low-aligned surface model, simplified power, super automatic image validation, and we also have a data simulation using the satellite data for the stratospheric ozone. And we have a long-term up to 7.5K and the 3D bar global data simulation system. And for data, we can follow the link. And our regional model is not has a dimensional scale models for N. Again, it's a hybrid sigma p coordinate, called E-grid, but we have a plan to migrate to the E-grid system. It has different mechanisms to handle the horizontal and the vertical, and we have its own RRTM radiation scheme or normal radiation scheme for driven the model using the same norm, main surface model as the global model, using the NYJ PBL scheme and temperature chemical scheme and back area microfluidic scheme. It's a plan that is running at the 12 kilometer 60-layer model. Our air quality forecast system, the main part is the chemical transfer model. Right now we are able to cover the whole U.S. Since last year September, and currently we are running our development model, including not only the ozone but also the PM chemistry. The whole model is similar to the CMAP working release 4.5, driven by the 1 at 12 kilometers. It's handling the national emission inventory for anthropogenic emission, and the biostream for biogenic emission, and mobile 6 for mobile emission. The aerosol version is similar to the aerosol 3, except we turn off the seesaw to assess our simulation. We use the SOPia to stabilize the PM module between the gas and the solid phase, and it is the same solver and using the common bond flow. And the new improvement is including the symmetric convective model SCM2 PBL version. For the type 1, so use SCM1. We are an operational unit, so there's some requirement we need to do is that we need to use our own meteorology model. The reason is that anything happens after the global model finishes the meteorology, regional have to follow. And after you finish the regional chemical transform model, need to start immediately. So it need to be connected seamlessly. If anything wrong, we need to be handled internally and very fast. So that's why we need to demand that every model needs to be run at our center. And our IO format, which need to be, whatever in the future need to get our data or use our data, then is only the machine bias is grid and buffer. This is WMO default format. And we also need to satisfy the display limitation because we have several models running at the same time. And the limit display, so you cannot operate too many your output field. And our time requirements is basically we are using the 12G 48-hour forecast, need to be available 5 hours after the start of the 12G run. And our 06D simulation need to be finished and all the file will be available at the 13G. Therefore, the state forecaster have enough time to look at our result and issue the air quality status for today. We are running a 65 node, the IBM Power 4 process machine done Actually, for the air quality system, we probably can only use about 13 to 18 knots, because other models also need to know. And our 12G normally is started 2.5 hours after the work element. So we don't have, our model is that running 4 cycles per day. So every 6 hours, all the majority need to cycle again. So our model also need to be rerun. Therefore, we only have 2.5 hours and 2.5 hours, probably at most 3 hours to finish our product. And because our model is responsible for the forecasting, so we need to be maintainable forecast. We cannot interrupt the operation on this one-day forecast. So we need to structurally test and evaluate with retrospective or real-time experiment. And all the products available throughout National Solar Service Gateway, NCEP, and need to maintain 99% reliability and 24 hours, 7 days per week support. And in order to have our operation model running, we need to ask to be satisfy the 90% exceedance the heat rate. The data for our air quality modeling forecast system is that soon after the meteorology model finish, you need to run through, in here we call the map preprocessor to produce the necessary meteorology field for the air quality model. We also need this is an emission processing to provide our emission data. We also need a global model to provide our initial boundary condition. Sometimes the IC actually is from the previous end of the previous round. And the output is converted from the next CDF to grid. This is our P4 format. And all the data has to go through our verification tool in order for us to understand how good the model is or if there is a problem. This is the schematic for how we start our run. Essentially, the meteorology model cycle every 6 hours, which means every 6 hours we need to get a new observation field, do the data simulation, and the rerun. And our model is that for the 00Z1, our two main forecasts used by the state forecast is 060 and the 12G. And for the 00Z, the AQN actually got the meteorology model data. It will run 6 hours to 060. Then it will dump for the IC to be used for the 06 hour. After the 060 meteorology model is available, we will run like 48 hours, 2-day forecast. Okay, and this is the major result that the forecast will look at first. And soon after the 12Z1 is finished by the meteorology model, the previous 61 will output another IC for 12Z1, and they will run another 48 hours. So this tool will be used by the state forecasting. Therefore, the other two runs we actually don't run. We do not run every hour for 48 hours, just run 6 hours to obtain the initial condition for the next cycle. After 2 cycles, again, the 16 runs can repeat the whole process. This is our meteorology model, modeling domain. The dashed line is the present domain, which is covered much larger domain than the chemical model domain. Then the solid line is the one we are ready to enlarge our domain to include Alaska, which is our next target area. This is the original operational domain for the eastern U.S. Actually, we start with the northeast U.S. first, and we expand to the eastern U.S. This is around 12 kilometers. This is a great number. And in September, we extend 2007. We extend our domain to cover the entire U.S. Okay, we still want to 12 kilometers, but nearly double the grid. And our next target area is to include Alaska and Hawaii. Although this way the cell doesn't have any ocean issue, for Alaska sometimes will experience some PM problem. But this is enabled by the computer because you can then make the US effort. The one thing important for our center is to provide the air quality product for the state forecaster. Use it as a guidance to issue the air quality forecast. Therefore, communication with the air quality community is the very most important topic. The following is that we just provide some examples of what kind of product do we provide, and you can see the entire suite of our products in this website. For example, this part we provide the entire US model prediction. For example, this is the first day AR mass, or you can select. There's a pull-down menu that you can select the second day AR mass ozone or not, and the time of day. And you can also select the regional area enlargement to look at the regional or even detail state-wise. We also provide the magnification to include the model output, that's in the contour, or the observation result, which is in the circle. Therefore, we can see that the two colors are identical, which means we predict very good. If it's not, either it's the over prediction or it's under prediction here. So this not only allows the air quality community to obtain more information for their forecast, but we also rely on this to study when does the market do good or bad. This is another example, is 1 hour and 24-hour average for the PM forecast. This is my mental run, which is we are currently pushing to get into operational state. And you can also select a different area which has ozone zone or other something to provide a vertical profile of the gas phase and the PM product. And verification is another very important task that we need to undertake. We need continuous verification, especially in real time, to evaluate the air quality forecast performance. It allows us to discover what the weaknesses of the model and whether there's a solution to improve it, and to identify any episode for detailed analysis in the future for the next generation of the air quality forecast system. Although we are covering the whole US, sometimes we do the entire US evaluation, sometimes we do the different sub-regional evaluation. So this is probably separate several different regions to evaluate our model. And this is an example that we can study different model run, different curve with different model run for the daily air mass ozone bias. Okay, actually this is two different domain. This is I just make an example that the red curve is the 3x. We don't have an Eastern US prediction, and the 5x are the entire US. But we are focused on the same area, which is only the Eastern US. And you can see that by including the entire US prediction, we actually improve. This is a bias compared to the observation. We actually the black curve reduce the bias, which is in the model performance. This is for summer 2007. This is summer 2006, which means that the transport probably simulate the transport actually improve our performance. We also have another verification which is using the satellite data to verify our PM model verification. And we can, at this moment, we can provide the daily average time series or monthly average for the selected threshold, or daily average for the selected threshold. We use several statistics score with a critical successful index, critical threshold bias, probability of detection, false alarm ratio, or forecast accuracy rate. So we look at all different statistics to find whether there is a consistent problem in our model. And by doing that, we'll be able to sometimes say, okay, at the August 2nd, 2007, the model did pretty well, which is a high open area which has been captured by the model. And sometimes we will miss although we predict that we will have a high order value, but actually the observation did not see, okay, both in the 5x or 3x simulation. Therefore, that allows us to track what is going on. This is another case from the Atlantic AR mass performance July 9, 2007. We can see that model capture partially the ozone exceedance, but it missed some area in a very near neighborhood. Therefore, if you take a look at the meteorology condition, this is the model forecast minus the observation. You can see that in this area, models seem to capture the condition pretty well, but below this belt area, we actually under-predict the surface temperature. Okay, this is one indication that the meteorology condition might impact our result. And this is another case of July 10, 2007. You can see that both 3S and 5S simulation under-predict our ozone disturbance. And if you look at again the forecast of the precipitation, this is the precipitation. The model at 18Z did not see any precipitation moving, but in the reality, we see the cloud and the precipitation moving. That's why we plot out all this the photolysis and the QOR ozone production there. Okay. This is another case of the 7. Again, we over-predict our result. Under-prediction may not be so serious, but over-prediction because we issue a warning, say, please stay home or something like that. So when you give a false alarm, it's very, very serious. So we actually studied this single case a lot. This is a satellite image. You can see that the cloud starts to move in. I'm sorry. This is in the New Jersey and the Maryland area. And you can see that the 15Z, the cloud starts moving into this area, and AZZ actually covered the entire area. Okay. But if you see, this is the clockwise, it's the 15Z, 18Z, 21Z, and 00D. You can see that the model see there's no cloud moving at the 15Z, even the 18Z. But actually, in reality, the cloud moving much faster than model prediction. That's why we also missed it, because that again the cloud kill over for the chemical reaction. Our future development for improving the air quality model is we start to move into including all the meteorology model and the chemical model under so-called ESMF framework, and in anticipation of the future online simulation, we can easily couple different models to run concurrently. And we also want to provide the PM forecast, as I said, soon this year. But we have two problems. We did not including the real-time fire event, which we had it has been shown that impact our PM forecast a lot. Also, it doesn't have a dust. And we are moving on to the next generation of the chemical mechanism from the carbon 4 to carbon 5. And as I just described, we are required to provide the forecast for Alaska and Hawaii. And we also want to provide the global dust and aerosol modeling to provide the weather boundary condition for the PM forecasting. Why the real-time ORFA data is important for our PM forecast skill. Here is last year in October, California had a very serious wildfire. In the satellite image, you can see that the wildfire smoke is propagated out of the California coast. And in our global stationary satellite coast, at the 21Z, you can see that because there's a large smoke particle there, so we have a large aerosol optical depth. However, in our model forecast, because we don't have this real-time Wi-Fi emission, so there's no emission in there. Therefore, we don't see anything pretty clear here. That's why we need to have the real-time input on emission in order to capture the spatial temporal distribution of the aerosol. this is our another future improvement, and this is just our temporary. We haven't gotten the conclusion yet. This is the simulation using the 2005 emission, using a carbon bond for the southeast or eastern U.S. and California area, and the lower two panels is using a carbon bond 5 emission for the same area. In general, we can see that when we use a carbon bond, use the same meteorology and same emission, the ozone concentration probably jumped 10 ppb up, nearly one scale up from here, like a little bit light yellow to a little bit like a dark brown and green to yellow. Okay, and this is indeed is a very serious issue. It's essentially occurred in California area. This is also one of our biggest target area. We need to have a very good forecast in order to have a new model or new model design to become official operational model. So we are still working on this, and at this moment, no one agreed that this is a good development. Something's still wrong. We suspect the emission still not very good. This is, as I already showed, is our current design for the air quality forecasting. Our new development is to provide a global chemical and transport model. It's to include the dust and the aerosol, does not include any gas stream. The primary is to provide a PM, data on condition for the regional chemical model, so they will do the forecast or provide a global field for the global forecasting air quality user. And the other issue is our dust and PM forecast actually will be feedback to the global model to include the radiation field. And in the future, when this part becomes an online version, the GFS can directly provide the chemical and PM boundary condition for the regional. And this model is a combination of two different models. The GFS global forecast system is our global meteorology model, and also the GLOCAR is the NASA global ozone chemistry aerosol radiation and transport model. Initially, we just finished the dust modeling, and we are waiting for the observation to do a verification. And the next step, we will include the aerosol model. As I said, the GLOCAR is driven by the global model to provide a 3D global dust and aerosol distribution. And after doing the verification from the satellite using the color AOD available profile, then we will provide the chemical and the PM boundary conditions of regional air quality model, or provide a global PM forecast system for operation of air quality forecaster. And in the future, these three steps will be lumped into the same step, and the result will be used for the chemical or PM data simulation and feedback to the GFS. So in the future, we are working on the online system to include these three. Presently, we are running the GFS offline, in the offline mode to test. And right now we have the 5 different dusting from 0.1 micron to the 10 micron. And I will show you some of my initial. I'm mainly responsible for this part, and I will show you some of my initial result between two different resolutions, T662 and T126. T662 is about 1.93 to 1.93 resolution, and T1 is nearly 1 by 1 degree resolution. I start my simulation continuous from the last December 3rd last year, and using cold start. And I'm going to show you mainly the second thing, and the surface data and the 700 millibar, and using the daily average. I'm going to show you briefly the two periods I selected, which is for instance with the dust storm warning in the Taiwan area. The first one is nearly the new year, is from December 31st, start to impact Taiwan and show you the actually I'm showing you the total, which includes the beams size 1 to 6. And the upper left is the result of the T62, and the lower right is the T1. This is high resolution, this is low resolution. I'm going to start with the December 26, 27, 28, 29, and 30 start the impact, 31 to start the decrease. Okay? And the major difference between these two models, you can see the T1 actually seems to simulate the long-range transport better than the T196, which is the so you can see that the dust storm from Mongolia actually can reach the U.S. West Coast, but in the T126 we did not. We did not see that. Okay, this is the first case. The second case is earlier this month. With the biggest dust storm, but actually I heard a lot of people say actually it's not materialized. But the dust storm start to appear in Mongolia in the 29th, and the impact of Taiwan, the biggest is around the 3rd. So here I'm going to show you, let me see, this is really the beam size 2. I'm going to show you the surface. Okay, the left two panel is the low resolution, T26, and T136 is high resolution. I'm going to show you the surface of the two panel, and also the upper layer is around 700 milliwatt. And this is 28, 29 start to draw. Second, third, when we impact Taiwan, and the fourth start to decrease. And you can see that the difference is that the dust start to propagate away into the mid-Pacific, but T62 seems to not be able to catch. Also, you can see that the 700 milliwatt, it will boom, send it to the second layer, and this layer has much larger, in the high resolution model, we seem to see much larger dust be pumped into the upper layer, and because of the stronger upper layer weight, it can be propagated to the westward much faster than the T62. Again, I said, so far this is just a qualitative analysis. We're still waiting for the data to verify our model, which we want to do a quantitative study. There are several sources from the aeronaut satellite, the orbital satellite, MODIS, GOES, or OMI. We also want to get the surface LiDAR data, which is a laser impulse. It can provide some vertical profile as well as a look down from the Callisto satellite. And the OMI profile to provide us some quantitative data to do our future study. So this is probably so far for this global dust model. That's it. Thank you.
Anybody have any comments or questions? In your higher and low resolution models, the vertical resolutions are the same?
Are the same.
They kept the same. Why could you not change the vertical resolution, especially when your long-range transport depends on pumping them to the higher level? The higher level is where you have a poorer resolution compared to the lower level. So why not increase the resolution at higher level?
Well, yeah, that's a very good suggestion. Actually, we are, as I said, this is our initial result. We are actually examining the vertical resolution issue. One issue is that we want to maintain the exact metrology offered by the global model. We do not want to do any integration. We're not going to destroy some of the dynamic or consistent issue there. So initially, we don't want to change that structure there. So we want to maintain the same structure output. Whatever we not given, we don't do any processing. We just use it directly. We just extract the logic field and use it.
Also, at this time, your chemistry calculation is offline.
Yes, for the dust, there's no chemistry included.
Yeah.
There's no.
But for your chemical modeling, there's an offline model.
Yes,
it's
it's
offline
yes,
model. You are using an online model, or do you see a need for that?
Yes, actually, one of our colleagues is responsible for looking at the email. He's going to use the next metrology model for names. It's on the liquid. And he's trying to implement all this process on the cement rather than form it into the name itself. So we are in the process of developing the inline forecast system.
Using what?
Name. The new model. It's quite different from the work.
Anybody else have fun?
You really show the example for private areas. So I'm curious about if any particular collaboration with the Taiwan research study the local process for private area. You just show the transport for private area.
Yeah.
And in Chinese, sometimes I see a slide in Chinese. So I think you have some very strong collaboration with Taiwan people. So can you say about this kind of operational collaboration?
Yeah, as I said, my duty is to provide the product of the regional air quality forecast and also global data simulation, which we are soon will start a chemical data simulation for the PM as well as some important gas data also to the blue field. But the data source is one issue. We know that Professor Chen has very strong model group here, so she actually wants to learn. One of my duties here to learn what kind of present research space they have. So then I provide what our requirement is, because we probably cannot transfer the entire package over because it may take too much time. So this is the initial contact to establish understanding between the design. Another thing is this is the initial contact. This WMO is the global dust warning system. They already have several meetings to start, but not materialized yet. So in individual company that has its own responsible country, in here in East Asia, probably China will provide a global output and provide any regional dust center that been selected the quality condition to drive the regional dust model. Okay, in the US, probably this model will be provided in North America, global, and our regional dust model most likely is the dust model in Arizona state, which they use a training is the regional dust model developed by the state. So I cannot say that what kind of collaboration because I'm not quite sure there's an interest here for which I know you have done some kind of regional dust modeling, but how do you want to provide from this area? I'm very interested to hear what kind of your interest on how we are doing over there. So then we can start our collaboration. Because there's a political issue here, so whether we can provide a forecast for this area, I don't know whether in the future will be a problem. But definitely, everything I showed you is available on the website, so we can always use it. For other things, I think we can discuss, and some of the issue I can bring it back to the machine supervisor, so we can continue our discussion.
Any other question?
One question. How do you assure that your model can always run smoothly you are running model on the computer, sometimes model may crash or the system may crash.
Yeah. I think probably to say how you prepare your model. First, you have to do a social study. Okay, how could the model is, and we have to run it. Okay. For example, right now we have one operational model. We have a new model. After it has been tested on one machine, and it will be moving to the same machine to run parallel for several months. So sure, it is robustness and the also studies performance. And we have two identical computer systems running every day. One is a main operation, the other is backup. Okay. They have identical software, identical architecture structure, identical compiler, whatever it is. Then when one crash, the other will soon back up to continue. If that's the computer issue, we will have one occurred like in the last month. But within a few hours, everything needs to be swapped. Okay, so we will assure the continuation of the operation. Of course, this is something to work, but we try to make up the time. If there is some issues, sometimes some people accidentally submit some jobs to wrong. We have another unit called central operational unit. They are computer experts, so they will monitor. Like 24 hours, people monitor the computer usage. Or different wrong. When something goes wrong, they will intervene immediately. And we have a lot of procedure. When this happens, what should we do? When the other happens, what should we do? And if you got a phone call in the midnight, and you have to go. Okay. So this is the way we maintain our robotics and continuation of operation. There's a lot of preparation to expect something wrong that we need to respond right away.
So university research is much easier than operation. Any other question? Any question from a student? You can ask in Chinese, you don't have to ask in English.
I'm asking my students.
Your high resolution and low resolution were almost D62 almost D96. Except the response to this almost even the same high resolution.
Yeah, except the resolution. For example, resolution different. And this over there, the vertical resolution are the same. All the numerical scheme, all the dynamic are the same. Yeah. The main difference is just change the horizontal resolution. The rest of it is the same.
But there's much improvement.
Huh?
There's too much improvement in the podcast, except the response of the use.
Yes, there is. If you go to the global modeling branch, they have all the statistics with the T1NCEP there. Actually, we are running T382 right now with much higher resolution. But I cannot run it, it's too long. But no, my model is still in the serial, not in the parallel. Okay, this model. So for one day, every day I need to run 1 hour CPU time. That's too long. Just for one day forecast, 1 hour is too long. If I run T382, that will be 9 times, 9 hours for one day. And I cannot finish this. Or I cannot now. But there are several results. Initially, we already think about cutting the upper layer, vertical layer, which we didn't see anything transport to that higher level. But we still need to wait to see what the errors will behave. Maybe there's a lot out there that we cannot do it. And the other issue is that once we cut here, if there's another volcanic rocket like the Pinatubo, which inject your soul directly into stratosphere, then we have to do it. We have to go back to 1D64 in order to cover the stratosphere. So there are several issues. There are several methods we are still waiting. Which one is good, which one is bad. We want to cut down the computation time and increase our model performance either by increase the resolution or using a much better emission profile.
Any other questions or comments? You also Okay, if there's no further questions, thank you again for your